Welcome. So in this lesson, we're going to be talking about quadratic modeling. Let's read this question before us. It says, Jenny wishes to fence off a rectangular vegetable garden in her backyard. She has 20 meters of fencing wire, which she will use to fence 3 sides of the garden, with the existing timber fence forming the 4th side. Calculate the maximum area she can enclose. Take note of the fact that I have highlighted all the key information in the question. This is something that you should very much do when you're doing questions for your exercise and also in tests and exams. Have a highlighter or have a pen and underline the keywords. The first thing that I'm going to do here, step 1, is I'm going to visualize what's actually happening. So I'm going to draw myself a picture. I find that drawing yourself a picture just helps to situate yourself a bit. Okay, so I have 20 meters of wire fencing, and I'm going to put up 3 sides of a garden and use the existing timber fence to form the 4th side. So I've got this existing timber fence. So this is the timber fence that's already there. And she's going to create a vegetable garden by putting up 3 sides from here, like that. So this would be the width, this would be the width, and this would be the length. So this orange part right here, that's the wire fencing. All right, so once we've done that, we're now going to move on to step 2. And step 2 is going to be creating some equations. Step 2, create some equations. So this is going to be based on what they've told us. So what have they told us here? They've told me that we have 20 meters of wire fencing. So in other words, I have some information about the perimeter of this thing, if I can spell. This 20 meters of wire fencing is telling me something about the perimeter. So I know that my perimeter is going to be 20 meters. So in other words, it's going to be my width plus my length. So I'm figuring out my perimeter here. My perimeter is 20 meters, and it's going to be my width plus my length. I could gather together my like terms. It's going to be 2w plus L is going to be equal to 20. Now this is all well and good to find the perimeter, but at the end of the day, I want to figure out what the maximum area can I form here. So how big of an area can I cover with 20 meters of wire fencing? So I'm going to have to create another equation for the area. Well, this is going to be pretty easy. My area is going to be my width times my length. But now we run into a problem here. How can I figure this out if I've got 2 different variables? I can't do this if I have 2 different variables. So what we're going to have to do is we're going to have to come back here, and I'm going to have to solve for 1 variable here. So I'm going to rearrange, and it really doesn't matter which one you solve for. I'm going to rearrange for W. So I'm going to make W the subject. So to do that, what I'm going to do is I'm going to subtract L and then divide by 2. And that will leave me with what W is equal to. So I know that W is equal to 20 minus L divided by 2. What I then can do is sub that in to the W spot up here. So sub in W is equal to 20 minus L over 2. So my area is going to be 20 minus L over 2, and I'm timesing all of that by L right there. So that means my area is going to be equal to, now let's be careful here, 20L, my L's don't look very good, 20L minus L squared over 2. To say this another way, I could say that it's 10L minus L squared over 2, if I just break them apart there. I now have created for myself an equation for the area. Now, it's very important that we get it in terms of 1 variable, because now that it's in terms of 1 variable, I can sketch it. So I can sketch this now because I've only got 1 variable that I'm dealing with. So to do this, I'm now going to use my CAS. So let's make this step 3. Sketch. Perfect. So we had step 2 was create equations, and step 1 was draw a picture. All right, so now I'm going to come over here. Actually, let me move this a bit so I can still see it. I'm going to graph this thing. Now, it's important that when you're graphing this, if you put into this like 10L minus control divide L squared, watch what's going to happen when I do this. Whoa. It's going to be like, what on earth is L? It's confused. So that means whenever you're graphing things, just do it. Oh, can I come back up? Do it in terms of X when you're graphing. So as long as you remember what it is, it's fine. And then it graphs it nicely for me. Now, as you can see, where is my graph? I do not know. So let's go menu. Let's go window zoom. And, you know, we can go to, what I like to do is go zoom fit. Like that. And then if you don't find that's good enough, you know, we can zoom out a bit. You know, play around with it. You can go window zoom box and you can put a box around with the part you want. That's pretty good. Escape. There we go. So what is this graph that we have created now? The x-axis is my length. So it's saying, you know, as my length is increasing, what is happening to the area? My y-axis is the area. Do you see there's a point at which I have a maximum area for the length that I have? If I go menu and I go analyze graph and I go maximum, I can find my maximum here. So my maximum area is my second coordinate because it is the y variable, so the dependent one. So my maximum area is 50 when the length is 10. So when I have a length of 10, I have a maximum area of 50. So I can come over here now. And having now sketched it, I can say the maximum area occurs at 50 meters when the length is, now what did we say? It was 10. Is 10 meters. And then of course, you know, if the length is 10 meters, we can easily figure out what the width is just by thinking about how area works. So if we come here, if I have 50 meters maximum, if my length is 10 times what my width will be, well, my width would have to be 5 in this case. And width is 5 meters. But at the end of the day, all they really wanted from us was this, 50 meters squared. So we used our sketching to solve that. Now, I just want to go through a few other things on your CAS that you need to be aware of. The first things first is that you have to be careful that you're getting enough decimal points when you're graphing on the CAS section here, on the graph section. To double check that, you have to go menu. Oh, sorry. You have to go back here for a second. Whoops. To double check that you've got enough decimal places occurring, what you have to make sure that you do, and let me just, so like menu, analyze graph, I'm finding the maximum from here to here. You have to go menu, settings, and then check what your float is. Sometimes you have to make sure your float is big enough to get enough decimals. Take note that you're getting the settings from here. You're not getting the settings from over here. So that's important to take note of where you're getting the settings from. Oh, there it was. That was my first one. Now, if you wanted to find the maximum through another means, you could. If I was to open up a calculator page, and let's talk about another way we could do it. We could go menu, calculus, and we could find the function maximum and then type in our rule. So it was 10L minus L squared over 2, over 2, and I'm going to solve it for comma L. So this is telling me that the maximum occurs when L is equal to 10. What I would then have to do is rewrite this. This is my area, remember, and say, well, what is this going to be when L is 10? It's going to be 50. So I'm saying, you know, for what value of L is this going to give me a maximum when L is 10? Then I sub that L back into my rule to get that 50 out. So just making sure that you can navigate your way around the CAS and you feel comfortable with it, changing the float size, just working your way around it is very important. So these skills are just very, very important, and you just need to make sure that you are feeling on top of it. Make sure you're reaching out to your teachers if you're not feeling on top of your CAS skills. It's really important that you are. All right, see ya.